Hey everyone, so we're going to do some application problems with hyperbolas. So let's just do a quick little review. We talked about the shape of the hyperbola, the equations for the hyperbola, finding the asymptotes, how to find the foci, and all of that. But we didn't talk extensively about the hyperbola itself. So I just want to take a minute or two to talk to you a little bit about it. By definition, a hyperbola is the set of points in a plane, the difference of whose distance from two fixed points, called foci, is constant. That sounds a little convoluted when you're just looking at the words, so let me demonstrate graphically what that means. If the center of my hyperbola is here, and my hyperbola looks like this, and my foci are located here and here. Okay, those are my foci. If I were to pick a point P somewhere on my hyperbola, if that was my point P, then the distance, I could measure the distance from point P to each of my foci. So if I were to go ahead and kind of draw in this line and draw in this line, and I were to call those distances, if I called this D1 and I called this D2, it says the difference of whose distance from two fixed points is constant. So if I said the difference of those distances is constant, it's constantly 2a, that's the definition of hyperbola. So no matter where point P is, whether it's there, or it's here, or it's here, or it's down here, it doesn't matter where it is. If I take the distance from that point to either focus, and I take the difference of those distances, that's always going to be a constant value of 2a. Okay, so what that means is that we will use the foci as our kind of fixed points when we're doing the application problem. So whether we're talking about microphones or transmitters or towers or whatever, we will put them on the foci so that we can use this property, which will allow us to find A, which will allow us to get the equation of the hyperbola. Okay, so that's our goal here, and that's how we're going to approach these problems. So let's look at the first example. It says an explosion is recorded by two microphones that are 2 miles apart. Okay, so let me just sketch in a quick axes here so that I can draw myself a picture. It's always helpful to draw yourself a picture when you're doing these problems. Okay, so let's see. It says explosion by two microphones that are 2 miles apart. Microphone 1 received the sound 4 seconds before microphone 2. Okay, so if I draw in my hyperbola, my microphones are going to be placed at my foci. And it doesn't really matter which side you put microphone 1 and microphone 2 on. I just happen to do it that way. We do have some valuable information here. We're told that our microphones are 2 miles apart. But before I write that down, notice that the unit of measure I'm giving for the rate of the sound travel is in feet per second. So I'm going to convert my miles into feet. The microphones are 2 miles apart. That means the distance from the center to one of my microphones is 1 mile. And there's 5,280 feet in a mile. So I know that this distance is 5,280 feet. And I know that this distance is 5,280 feet. And I know the distance from my center to my foci is c, so I know that this value is c. Okay, now let's go to the other information we have. It says microphone 1 received the sound 4 seconds before microphone 2, which means that that explosion occurred somewhere on this branch of the hyperbola. So maybe it was up here. I'm just going to put it up here. Right? What that allows me to do then is to figure out what 2A. If I know that this microphone is receiving the sound 4 seconds before the other microphone. I know the difference of the distances between the microphones is going to be 4 seconds times 1100 feet per second. My second units cancel there, so I have 4,400 feet. That's the difference of the distances between the microphones, which means that 4,400 is equal to 2A. And because 4,400 is 2A, that means that A is going to be 2,200. And what that then allows me to do is I now have A and I have C, so I can use C squared equals A squared plus B squared to find B. So I've got 5,280 squared is equal to 2,200 squared plus B squared. And if I just use my calculator and do that math out, I'm not going to show you that because I think you guys can plug that into the calculator. But we end up with B squared is equal to 23,038,400. They're asking us to determine all possible locations of the explosion relative to the location of the microphones. All that means is they're asking us to find the equation of the hyperbola that satisfies these conditions. So I've got my A, I've got my B, actually I have A squared and B squared. I drew my picture so that the center of my hyperbola was at the origin, so I know that I'm using the equation x squared over A squared minus y squared over B squared is 1. And remember with hyperbolas, it doesn't matter if A is bigger than B, right? It just matters where that subtraction sign is. So because I have it as a left-right hyperbola, the x term goes before the subtraction. So I have x squared over A squared, 2,200 squared. I'm just going to leave it as 2,200 squared. I think you guys could write that out and figure that out just by punching it in there. It's like 4 million and change, 4 million something. 840,000, something like that. I'm not totally sure. But you guys can figure that out. And then B squared, since I have it already, I'm just going to write that 23,038,400 is equal to 1. And that would be the equation for that hyperbola. And again, I know that one of the denominators, I didn't write it out just for sake of time. I think you guys could do that part. Okay, so that's the setup, that's the idea, that's how we're going to approach these types of problems. Let's go through that second example. It says that a ship is receiving signals from 2 different transmitters, F and H, with transmitter H being 200 miles due east of transmitter F. Okay, so that means transmitter F is going to be here, and transmitter H is going to be here. And I know that this distance is 200 miles. And again, we're locating our transmitters at our foci, which means that C here would be 100. Okay, it says the ship receives a signal from transmitter F 600 milliseconds after it receives a signal from transmitter H, which means that the ship is closer to H than it is to F, which means it's going to be on the right branch of our hyperbola. Assume that transmissions travel at a rate of 0.186 miles per millisecond. Write an equation for the hyperbola and find the location of the ship if it is directly north of transmitter H. So if this is my hyperbola, it's not drawn very well, but I think you guys get the idea. This is where my ship is, and I'm just going to put that as point J, right, because I'm due north then of transmitter H. Okay, so again, we're going to find the equation of the hyperbola. Again, we're going to find the difference of those distances. We're going to find that value of 2a. So remember, we're just going to take the 600 milliseconds and we're going to multiply that by 0.186. I'm not writing the units in here just in the interest of time, but you'll see that milliseconds cancel out, so we end up with 111.6 miles. Okay, that's our 2A value, which means that A is half of that, or 55.8. Okay, so I know what A is, I know what C is. Again, I can just use my equation, c squared equals a squared plus b squared. And I've got 100 squared is equal to 55.8 squared plus b squared. And when we do that out, we end up with b squared is 6,886.36. Okay, so my equation, again, it's going to be x squared over a squared. So 55.8 squared. In this case, I did it out. 3.64 minus y squared over b squared, which we already know is 6,886.36, is equal to 1. So that's the equation for the hyperbola, but it also says to find the location of the ship if it is directly north of transmitter H. Okay, so if I'm directly north of transmitter H, what can I do with that information? If I'm directly north of transmitter H, if this is my center, I know that I'm going 100 miles this way, and then I'm going y miles this way. So I know the coordinates of this point are 100, comma, y, right? So I can plug 100 in for x and then just solve for y. Right? So I have 100 squared over 3113.64 minus y squared over 6886.36 is equal to 1. If you move this other fraction over to the other side, subtract it from 1, and then multiply both sides by 6886.36, we end up with, I'm just not going to show you those steps, because I think you guys know how to do that. We end up with y squared is equal to 15,230.39, and so then y comes out to be about 123.4 miles. And that's how far, that's the location of the ship if it is directly north. It's 123.4 miles north of transmitter H. So those are some application problems with hyperbolas. The setup for all of them is the same. Remember that you're using that information about the time and the rate to get the distance, and that distance represents 2a. Hopefully this helps, and we'll see you next time. Thanks, everyone.